Thank you so much for having me here. Happy to talk about Apertus. First, a few words about myself. I'm Imanol Schlag. I'm a research scientist at the ETH AI Center. I've done my PhD with Jürgen Schmidhuber a few years ago, and now I've been fully working on Apertus, and that's what we're going to be talking about in a moment. I'm really sort of a connectionist researcher, as we would say, so I think about artificial neural networks. I think about how do we change the design such that they generalize better or scale better. AlphaFold 3 is a great example that we've seen of how the neural architecture was changed in order to fit to some symmetries and become more data efficient and so forth. And something we developed is like the DeltaNet, which is now a component that is of growing interest to the largest models that have been developed, in particular models coming out of Chinese labs, since there we know how they've been built. And I probably don't have to tell you that AI is really sort of changing the world. We see adoption all around the world for general assistance, but also for novel products and services, and adoption throughout different tasks. In particular, the younger generation is picking up these tools much faster than others. There are now people who are going to grow up with AI tools available to them that can speak, that can interpret videos, that can interpret images and audio with no problem, and also generate images and video with no problem. It's going to be a completely different world. And it's not really that surprising if you look back at it, because what we have seen over the last 10 years is really relentless progress in the development of AI models. Initially, 10 years ago, you would train a model, 10 years ago, you would start training models, because before that, you had good old-fashioned AI where you wouldn't do machine learning. And then what we've seen is you would train a model specifically in one domain for one particular task. And what we've seen now over the years is that these models have grown larger, and they became more capable doing multiple tasks in a domain, then starting to do tasks across different domains, so not just language, but maybe also code. And now even we see models that are doing it across different modalities as well, not just text, but also image and audio, all in one model. And they're benefiting from each other. And here is where the previous slide here is like x-axis years. Here we have a slide of months. And we can see much more challenging benchmarks that have been created, since with the relentless progress of AI, there's always been new benchmarks that have been created to measure what is the current frontier. And these ones are particularly challenging using software development tasks, as well as Google proof question answering tasks, as well as software high-level math, university-level math challenges. And we see that models throughout the board, open and closed, are making here still relentless progress and improving these models. But who is actually building these sort of models that are available? There's three types of classes, or three classes of models. We have the closed models. These are the ones we're most familiar with. They're driving adoption and they're driving performance as well. This is the ChatGPT, the Claude, the Geminis that you know and you probably use. However, they only share the outputs. We don't know what's in there. Since over 3 years, they've been developing them behind closed doors, and often we also don't know how they've been aligned. More on that in a moment. Then there's the open weight models. These are models that you can actually download and run on your own hardware if you have powerful enough hardware. This is where the Chinese companies are really dominating as a way of also catching up. Maybe you've heard of the GLM5 model. It's quite comparable to Sonnet 4.6 on benchmarks. The Quen model from Alibaba has been very popular as well. There's also the Llama model from Meta, actually, which is an American model. But what is also a trend here when it comes to the open weight models is that most of them are, well, all of them are coming from a tech company, and most of them are becoming closed models. So they go from the middle to the left. Like the Llama models are not going to be continued by Meta. The Quen models are also seem to be unlikely to be continued on from the ZAI. We know that the next version, their Frontier flagship version, is not going to be an open weight model as well. And we also know that from Mistral. So it starts to become much more sparse in the future. And it's not quite clear what you would build on if you are going to use a model of a generation in the future. And what we have here on the right is the third class, which are the fully open models. These are models that are fully transparent about how how they've been developed, they've been transparent, how they've been aligned, and they're also available for you to download and deploy. And these are really the models that are coming out of public institutions mainly. Famous ones are the Olmo model, for example, from the Allen Institute of AI, as well as Apertus that we're going to talk about. And there are other models that have been developed, like the K2 from NBCU AI and other smaller models that came out of European initiatives as well. Some of them are developing bigger models as well, but they have not been released so far. Here, there's also change. The Olmo model from the Allen Institute of AI is a very popular model. However, it's only English and only focuses on the American ecosystem. And also, the half of the Olmo team, as well as the leadership that developed Olmo at AI2, was recently hired by Microsoft Superintelligence. So that means that model is also not going to be continued moving forward. So it's looking more and more there. And so why do we want to develop our own models? Like, there's various problems with these models that are available. They're developed and aligned in ways that are not involving us. On the top right, we have Gemini generating images according to DEI principles we may not follow in Europe. On the left, top left, you have the kind of exact opposite, with Grok going completely nuts and asking, well, I don't have to spell it out, I guess. And on the bottom left, you have DeepSeek, a Chinese model, which gives you a Chinese government opinion when it comes to Taiwan, which you have no control over. All of these Chinese models come with this sort of bias. They've also been developed in ways that might not be aligned to our ethical or legal principles. We know that a lot of these companies have been using data that comes out of illegal sources. Some of them, they do it in a sort of semi-legal way, like Anthropic. They actually bought lots of secondhand books and then destructively scanned them in order to train on them. Is that appropriate or not? This is for the court cases to decide. And lastly, there is also a regulatory gap. So apart from being undemocratic and untrustworthy and not really representative necessarily of our culture or languages, because most of the Chinese models are trained on English and Chinese, and the American open weight models are also mostly English and high resource languages, like we know from Olmo, for example. They are all also having a regulatory problem when it comes to the European Union, where we have the EU AI Act, where it actually requires a certain transparency. And here is one example I can give you. On the top left, you have like a sentence as it comes out of a regular technical report or model card that describes the content of the training data. And on the right, you have a section of the EU AI Act on general purpose AI models, which is already law and is going to be enforced in August, although I've been told that this has been delayed as well a little bit, because it necessarily asks for a detailed summary of the training content to enhance transparency, and none of the open weight models is currently fulfilling this. So why do we want to build our own models? It's a legal necessity if we want to do it as a public institution. We also want to maintain our research and development autonomy because the open weight models are not reproducible. We don't know what data they've been trained on, and so it's not necessarily scientific to build on those. We want to also have control over how they're deployed. If we only rely on providers from foreign tech companies, then that comes with certain risks. And we think that this is the technology that is going to be defining our time, just like the smartphone did, or the web, or the personal computer. And so we need to understand how this technology works and how to develop it further. And we believe that, as Feynman said, that what I cannot create, I do not understand. And so this is why we came together, the EPFL, the ETH Zurich, and CSCS, to develop and release Apertus. So what is Apertus? Apertus is a fully open and transparent and responsibly trained large language model. There is two, one at 8 billion parameters and one at 70 billion parameters. They've been training on ALPs on up to 4,000 GPUs in a model parallel way on 15 trillion tokens of text. This is essentially very comparable to Llama 3 from Meta, which is a previous generation model, so it's a dense model as well. And we have done this with responsible data practices that I'll get into in a moment, but also very multilingual with basically over 1,000 languages, way over 1,000 languages that have been included. So over 40% of the data that we trained on is actually non-English. If you do a fair comparison when it comes to large language models, then you have to compare them by the amount of compute that you spend training the model. That's the main factor that determines performance. And in a large language model, that means the size of the model as well as the amount of data that you've trained on. And here, Apertus compares very favorably with other models on English benchmarks like the Llama 3 that was our sort of North Star, and the same also for 8B. At 7dB, there's not that many models to compare with, really. 8B is much more competitive because that's a scale where you don't really need model parallelism. And lots of people and institutions and companies have developed models. And here, the 8B Apertus model is actually excellent. I could show you our own plots, but I thought it might be more convincing to show you third-party evaluations where Apertus is compared to models from the likes like Alibaba, Cohere, Mistral, IBM, and pretty much any public institution that ever developed and released an 8B scale model. So this seems to show that we're doing something right. It's also completely open how the model was developed. We have a technical report that you can see here on the right, which has about 100 authors. This kind of shows you also the scale of this effort. Most of these people are actually, fantastically, are PhD students, postdocs, and master students. There is a smaller minority of engineers from CSCS as well as engineers directly working on the AI questions, the application layer in the Apertus team that I lead, but the majority of this is done through these sort of volunteers. And we release in this almost 120-page report basically everything that we can think of that we did that would matter, including also a GitHub repository, GitHub organization really, that contains several repositories with code to reproduce the data, to do evaluations the same way that we did, and also how we did train the model, including also a lot of model checkpoints which are valuable to researchers. Now, when it comes to training the model, what we did different, or how we distinguish ourselves, is that we actually have a bunch of innovation that came out of ETH Zurich and EPFL that went into the model. So the model is not just Llama 3, it's actually better than Llama 3. It has slightly different components. It was trained with a different optimizer. And when it comes to data, we have applied responsible data practices. In particular, we only used data that is publicly available and versioned. This means that there are illegal data sets or data sets that are from illegal sources, shadow libraries on pirated content on the web that we categorically refused. And we even went further to respect a certain AI opt-out based on the robots.txt of the web crawled data, which makes up the majority of our data. We do lose some data because of that, about 8% of English data, 4% of non-English data. Most of that is the media domain, but we have some peer-reviewed published work that shows that this does not really affect the performance of the model. We've also done something quite unprecedented at this scale, which is to prevent the memorization of the training data in order to address copyright, because we do train with data that is copyright protected, but we make sure that the model does not memorize and spew out this copyright protected works anymore. Because copyright, as you probably know, is not about the idea that is in your document. It's about the physical manifestation, or the exact manifestation of your idea that is protected. This is a plot that, thanks to our transparency and our multilingual training data, no one else could show you. In particular, what you see here is in this pie chart, 40% of the data, which is non-English, 60% is English. You can see here the distribution. If you're surprised that Russian is so large, I remind you there was a big country called the Soviet Union. There's many countries that still use the Russian language and have a lot of Russian documents. So that's a good reason why there is a lot of Russian text on the web, and Mandarin or Chinese is much less represented, partially also because some of these web servers are refusing crawlers that access them, which, by the way, are not our own crawlers. These are mostly coming from Common Crawl, a non-profit organization in the US, which crawls the web and shares that data for search engine development, but nowadays also AI model training, but more on that later. Now, we have a long tail of languages that we included, which of course doesn't mean it means that we have a lot of languages in our training data, our pre-trained data, but it does not mean that the model is conversational on those languages. It means it's a very strong multilingual foundation. Now, it is conversational in a few dozen, the one that we introduce in post-training, which is much more curated and higher quality data. But also, it allows us to now, because it's so multilingual, it allows us to improve performance or achieve conversational capabilities in a model through relatively little effort. And one example, a little anecdote I want to give here, is the performance that the model had on Swiss German. Swiss German is a dialect that is written in social media, but not really in any official documents. We always use High German in Switzerland. It's an Alemannic dialect, however. And all we did in order to get the performance of basically zero, because initially the model after post-training would refuse or would not speak any Swiss German. It would essentially produce High German and claim it was speaking Swiss German. And we were able to go from essentially zero performance to, let's say, a decent 40–50% performance by merely adding a few thousand conversational examples of Swiss German. And this kind of shows that the multilingual foundation really makes this a great basis for the further development and tuning of the model for particular cultural and language niches. We have already seen this to some extent, where I believe Estonia has fine-tuned Apertus for the Estonian language and the Estonian culture with great success compared to other models which lack this multilingual foundation. An important detail that is maybe the least technical in our release is also the Swiss AI Charter. It's a document that describes how the model is supposed to act in different situations. I remind you that the post-training is really the phase that tunes the model's behavior. You can think of it almost like behavioral training. And often people speak about reinforcement learning from human feedback, where a human will provide feedback to which sort of completion would be preferred. But nowadays, or at least the way that we do it, is a constitutional AI approach, as Anthropic calls it, or essentially an AI judge that, given some sort of document, judges which completions are preferred and which ones are not. So what you need is a strong model that is good at instruction following and that understands your document. And by doing so, we're actually able to align the model without the need of any humans that are not just costly, exploited sometimes, and takes a lot of time, but we can do this much more efficiently with much more control that is less biased. And it's a short 2-page document that describes the principles, and if you're interested in this, I invite you to look at Appendix O in the technical report. Now, all of this wouldn't have been possible without the ALPS research infrastructure. You all know it is over 10,000 NVIDIA GH200 GPUs. What we ended up doing is train on about 4,000 of these GPUs for, 3 months is like what the sort of efficiency is that we would have now to train the 70B model, which is a dense model as well. And this was really a challenge to get there. You've seen this slide before from Thomas as well, where this is the throughput we had at 70B scale at the beginning at the top, and on the bottom you see the changes afterwards. There were some interesting anecdotes because we were looking at this and we were not quite sure if this is a problem on our end, where somehow maybe our configuration of the parallelism was not ideal enough, or some problem with our data. But what we then saw as well is that these drops, like you see on the very right there, where it essentially goes to zero, I've been told that this was actually someone essentially DOSing the storage system, and with that person then sort of stopping that behavior, we were then able to recover some of the throughput. So that was an intense collaboration between CSCS engineers and the Apertus team in order to achieve the efficiency that we have now today. So where can you get Apertus? Apertus is mainly a model. It's not a system, so it's not a product that you can buy, that you can directly use. Also because as a public institution, we're not interested in providing a service for a subscription fee or whatever. And so the weights of the model, those are available on Hugging Face. They can be downloaded and used commercially as well. They come with an Apache 2 license, and they've been downloaded about 1.8 million times by the end of the year, over 2.2 million times to date. And they're also available, the model itself deployed is available on a bunch of cloud providers in Switzerland. Infomania stands particularly out because they have a service where you pay per token, so it's quite comfortable. But also Swisscom, for example, has an offer, and on AWS and Azure you can deploy the model as well relatively easily, if in just a few clicks, if you have the necessary resources, the cloud resources reserved. You can also run it locally, of course, and luckily we do have a third party that allows you to kind of try it out immediately. That would be publicai.co, which is a non-profit organization that is separate from us, that provides the model for you to test. Now, if you do go to that website, make sure you log in as well, so you get the 70B model, which is a slightly better experience than the 8B model, and also make sure you enable the web search, so you actually also get up-to-date information when you ask it about who you are, and then you may be surprised how good it actually is if the web search actually finds your website or some information about you on the web. So we are working diligently to not just make this model an interesting research artifact, but really also something that industry can adopt to build products and services. And for this, we have created the SME Circle, where we are in touch with some of the startups that are interested in building novel AI products and services and care about where the data goes and don't just want to be a wrapper around OpenAI or Gemini or from Google or Claude from Anthropic. But there's also opportunities for funding. In particular, we are quite glad to have Swisscom, the national telecommunication provider, to fund our research as well on a strategic level. And in the end, what we are doing is we are going through this release cycle where we have now developed and released Apertus 1. There is, of course, a lot of things that are great about it, also a lot of things that are not as great about it. And we have been working quite a bit since the release of Apertus 1. And we are now closing this loop for the first time. And we intend to close this loop multiple times over the next 5 to 10 years to really make this a maintained effort where we want to develop models that are continue to improve and give you a reliable and a sort of a sovereign alternative to the, let's say, frontier models that are out there, such that you can maintain full control over this goals. Will this essentially achieve the sort of replacement of ChatGPT or something like this? Well, probably not, because the frontier is moving fast as well. But we are now there where they were maybe 1.5, 2 years ago, and with the next models that are going to come out, we are going to try to close this gap even more. And I don't think that there's any magic sauce that is being added in the development. I do believe that we can actually achieve what we have now in the closed models in the open in the very near future, if we just do the work that is needed to do so. And so one example of this is the development of Apertus 1.5, which is ongoing right now. Pre-training has basically concluded, and we're about to post-train this model at the 8B scale. This is a continued pre-training of Apertus 1, and it's addressing two of the main things that developers were asking about. In particular, developers would like to see image input capabilities in order to enable new interesting products and services, and they also wanted to have a model that is better at following instructions and using tools, which is also quite powerful in order to build more interesting and capable and useful AI systems. And I'm happy to tell you that these are exactly the two things that we decided to work on. Here's a little sneak peek of some initial experiments where you provide an image and you ask them all to describe it, and it gives you a very accurate description of the image. These are surprisingly good, really. With some preliminary experiments, we saw that the model would make smaller mistakes, or it would confuse maybe a building or hallucinate a building or confuse some sort of letter. Here also is an example that shows the OCR capabilities. It might be, maybe it's a bit small to read. Let me assure you it's actually accurate. And funny enough, these examples are not really cherry-picked. We have like 10 samples that we use throughout, and literally 9 of these 10 are doing very well, and one is a bit off. But what we're seeing in particular is that as we keep training on more data and as we keep increasing the size of the model, because some of the ablations we did with even smaller models before, we see that the performance is just there. And so this reinforces as well that there is not really necessarily a big secret in how to develop these models. It's mainly data and compute. And so lastly, I want to end with this slide, because I do believe that AI is changing the world, and it comes back to the beginning. In particular, I think intelligence is going to be a commodity, especially like, let's say, digital intelligence. Think of anything that a worker can do remotely. It's going to be abundant, it's going to be cheap and transformative. But this AI infrastructure and software will therefore also become increasingly critical to our economy and our daily lives. I mean, how many of you are writing code and already like kind of not willing to give up on your cloud subscription or your Codex subscription. And so it's two main risks that are being introduced here. It's a dependence of a handful of foreign providers, and the two things are whoever controls the development of these models will be able to decide how these AIs behave. Maybe these AIs are not always going to have your best interests in mind. If that AI notices that you're trying to do something that goes against the interests of the organization that developed it or the country in which it was developed, then it doesn't matter if it's running on your hardware. They have such a large attack surface and they're so interconnected, they may be able to leak your private information outside, or they may be able to refuse to help you or actually actively sabotage you. And it's very hard to find this sort of behavior in the weights of a model because they're a huge black box, and it's very hard to make progress in interpreting the weights of the model. So you will only know it once you actually figure out an example where this triggers. And the other problem is that whoever serves you these models will have access, increasingly access to your sensitive data, because the models are doing best the more they know about you, the more context they have about you. And we're moving quickly to a future where people are readily sharing all of their emails, all of their documents, everything they have on their Google Drive with the model just so it can do slightly better. And this may not be something that we would want. And so I think that we need to invest in the expertise and the infrastructure to build and evaluate and deploy these systems on our own terms in the future to address these risks. And with this, I conclude. Thank you so much for your attention, and I'll be happy to answer any questions if you have some. Thank you.
Thank you, Imanol. Okay, first question.
Thanks for a great talk. So I can address this from the Swedish point of view, because we're a country now, a smaller country that want to fine-tune our own models, right? And what you realize in this business, there is an exceptional interest from all vendors, be it Mistral or NVIDIA and everyone else, because they all have a very strong strategic interest in getting you under their umbrella so that long-term you're forced to work with them. Now, the challenge is, of course, short-term, they have very large resources, they will support you anyway, and they have outstanding models. So short term, there's a strong incentive to go with these models because they're, quote, best, unquote. While it's a fairly challenging situation to argue that, well, it's better for Sweden to join these efforts that are truly open because these models might not be the strongest yet. And I guess this is a common challenge we have. So how should we approach this to make sure that we get more of these projects that we lead and invest in them?
I think it's a great question. Thank you for that. It's definitely a challenge. It's a particular challenge if you're operating in a domain where performance is all you care about, right? And these are the software developers working on their code on the side project that, doesn't really matter. But there is, I would argue, plenty of actors, of stakeholders who actually care more deeply about where their information goes. Sovereignty is not just for nations, it's also for companies. They have intellectual property that they want to share. You may be developing newest insights in your research that you are leaking on a minute-by-minute basis to OpenAI, which has every incentive of making use of your latest research potentially before you have patented it. The same maybe goes for Google, who even have isomorphic labs, part of the Alphabet corp, in order to actually exploit exactly that direction. And so I think there will be a growing interest in keeping certain information private, and this means that the models need to be deployed on a trusted inference provider or locally. Most likely in the future, it's going to be a little bit of both, where the day-to-day speak stuff, just writing text and interacting with you is done by a local model that is reasonably intelligent, and the more complicated things are then outsourced to an inference provider that you trust. But what model are you going to host there? Is many people have problems with hosting a Chinese model internally. There is a Swiss company that is claiming to have an ethical cloud. In the end, what is back there is actually a Chinese model. And if you go and you ask about it, it will say so. It will give its name. And this then actually, for good reasons, some people feel like is a conflict. So it's about finding that niche and making sure that we are serving that community as good as possible in order to maintain the development and of these models, because it's just a question of time. Compute is improving exponentially. I don't think there's a reason to believe this will stop, despite Moore's law not being a thing anymore. And yeah, it's a matter of time until we have models that are just as good as the ones that are now in the US. The question is, like, if they become so good that now suddenly we will stop developing ours, you know, if there will be reasons for us not to release our models or things like that. And I really dislike what some of the US companies are doing, like Anthropic with Mythos, that you maybe have heard, which made the news for finding a lot of security issues and bugs that they now have only released to trusted partners. These are not capabilities that just emerge at scale. These are capabilities you're actively working towards. And so they kind of work towards certain capabilities and then seed fear around those. And I think they do it in order to make sure that they can have a successful IPO. And I disagree with that. So I think there is a place, and it's about finding our community and making sure they're served best.
Thanks.
I have a fast question. What's the next big things for Apertus?
So Apertus 1.5 is what we're working. Image capabilities, tool use capabilities, things that really should make it much more interesting for developers to build interesting products and services. But we're also working on Apertus 2, where the goal is really to train a much larger model, a mixture of expert model, that our first results show we can actually train even more efficient than the Apertus 70B that we've trained so far. That will close the gap with some of the open weight models that are currently leading from some of these Chinese labs, because they're not fully transparent, but they do share some of their methodology, some of the things they've been doing, and it really tells us that or gives us confidence in what we have to do in order to reach that performance as soon as possible.
Thank you.
Yes, sir.
Thanks, Imanol. Could you imagine that, you know, this track of increasingly large models is, you know, going to be like a dead end, and people would work towards, like, you know, more agentic systems or small language models where, you know, each one is more specialized?
Oh, absolutely. I mean, it's still true. Larger models will do better. And the trick is that you then use a large model as a teacher to train much smaller models through distillation or by just generating high quality data and really distill only the most important and useful capabilities into the smaller models. That's something we've already seen. Gemma 4, for example, is a great model. There's also a Gemma 4, well, there was a Gemma 3 8B model as well. Gemma 4 is MOE now, so it's not directly comparable to Apertus 8B. But what made it so much better, well, so much not, but it was better than Apertus 8B. And the reason is it's distilled from Gemini, actually. They are distilling Gemini models into Gemma at with a certain cap on model size and capabilities, so to not compete with Gemini. But this is why they're doing so well. And we've already seen this as well ourselves. We've been keeping track of the predictions of the biggest models over the last trillion tokens of high quality data we trained on. And this, despite needing a lot of space on the storage system of CSCS, was actually quite useful to train a few very small models. And it looks like, we're not quite sure yet, but I think they're actually very competitive, if not the state of the art at that size. And so this is really the trick. You train a big model, but you don't expect everyone to host and serve it, but then you use that in order to train much smaller and much more efficient models that have also a smaller memory footprint.
Any other questions? Yep.
when you're moving into multimodal models, are you doing anything with audio transcription and specifically speaker attribution for kind of processing audio and video?
So the model is trained on images and audio in the same way as it's trained on text. So in theory, it could be generative, a general purpose generative model, but we are training it and releasing it in a way that only allows for image and audio input capabilities, not generational capabilities. Will this be enough to do speaker classification or transcription? So we are definitely looking at transcription because there's some interesting research out there that shows how you can interleave transcribed text with the audio in order to improve the alignment between like the audio representation and the text representation. And this is quite crucial because the model learns a representation for images and a representation for audio and text. And if you don't have parallel data in order to cover that bridge, it will claim to see something in image or in an audio script file, but even though it is not there, this is like the things we've seen maybe a year ago or 2 years and now much less. When it comes to specific skills like speech classification, it depends on if we have this sort of examples of this behavior, of this sort of task. And I'm not sure we have it for speaker classification. In general, audio data is much harder to get around. So we rely a lot on the community that is out there, the open source community, the research academic community that builds data sets, that collects data, makes it available. And we also have a pretty high bar when it comes to the data that we are allowed to ingest. So if there's a data set that is share-alike license or that is non-commercial, we actually are not using it. And this can hurt our performance in certain places, but it's a trade-off we're willing to do. And so speech classification, I don't have preliminary results, but transcription actually is quite exciting and seems to do pretty well. And in particular also on low resource languages, because for some low resource languages, we have barely text, but we have a lot of audio. And especially the approach that we took, which is a bit novel compared to the other omni models or completely multimodal models out there, is that we can also train on non-parallel image and audio data. And that we have recently shown through a thesis of a student that it actually can improve performance. So we're quite excited to see what there is, and it's going to be a first version. And if speaker classification is like something that an industry really wants, then we'll be willing to also, think about how we can improve in this direction.
Thank you for the talk. Are there any key architectural features of large language models that give them an advantage with multilingual applications? And are any of these architectural features implemented in Apertus or coming in the future versions?
So the main thing that comes to mind is the vocabulary. So as you have text, you need to convert it into tokens, and this vocabulary needs to support a certain language. Otherwise, it will fall back to byte level representations. And so that means if it's a language that is not represented by ASCII, but requires Unicode and the vocabulary does not take it into account, then it may require like 4 or 5 times the number of tokens in order to represent that that text, and it would be hence also 4 times more expensive to use. And now this is something that we are looking at to have a vocabulary that has achieves more parity when it comes to compressing languages or text from different languages and cultures. It's quite difficult to make this as uniform for all of the languages, but it has definitely been doing a better effort. So what we have used so far was already a pretty good vocabulary when it comes to this, but we have work in place in order to improve that even further.
Time for one more question. Okay, thank you. Imanol Schlag.